Galera, a gente tá aqui numa escola privada aqui de Xangai, top 3, uma das 3 melhores escolas aqui de Xangai. E quero apresentar para vocês um pouquinho do que eles têm. Então, depois de fazer um tour na escola, a gente vai se organizar. Percebam que tem as mesinhas com os nomes. Então, cada um vai sentar no seu lugar determinado. Tá aí o Vagnão aí, ó. Tirando a sua fotinha.
Aqui no gabinete.
E aí? Aqui tá o meu. Eu tô aqui do lado do Vagnão. E eu vou estar mostrando aí um pouquinho do que vai rolar aqui pra vocês. Tá legal, agora? Eles reuniram a gente numa sala. A gente vai ter uma conversa. Pra ver que eles se preocuparam ali com a bandeirinha Brasil-China. Os pessoal vem chegando aqui, ó. A gente vem conversando muito sobre as escolas. O rapaz ali, ele é professor de matemática. Desculpa, ele é professor de arte. Ele tá por aqui. E é mais ou menos sobre isso. Bom, o que der pra filmar aqui, eu vou filmar, tá bom? Mas essa escola aqui, ela é muito boa mesmo.
If you don't have a new routes, feel free to I'm not thinking.
Maybe we should decide to start on one first and just next the party of the
Matching.
or the quality of this is how it goes, but then it should be
Like these long form are not the same with I just thought this.
okay.
So
Winning. What is winning? You know, lots of line graph. Yeah. Why is that good? It's because there's a side of the hierarchy. Yes, it's a pure only. Yeah,
But everyone knows that's not right.
that's all the
yeah.
This is a function graph shape and we don't you have to agree with it. Okay. Yes, what do you need? Okay, thanks. Any volunteers want to share with the class your match? Anybody care? Okay, Amy.
So, wait, do I just do one of them or?
You can start with the bacteria.
Okay, for bacterial colony growth, we chose graph C, which is the
Graph C,
exponential function.
exponential function. Yeah. So
Because
the equation is
the equation is a times e to the b plus.
so it is Z, right?
Yeah,
Okay. Give us your reason.
because the graph shows unlimited growth at increasing rates, which matches how bacteria would double every hour with unlimited space.
Yeah. Unlimited resources and double every hour. So this emphasizes that it is an exponential relationship between the independent variable and the dependent variable, right? And for the second one, Ferris wheel height. Maybe William?
I think Ferris wheel height match was A and like was A and X. Because in the Ferris wheel, imagining yourself like sitting in that chair, like it's a like the height is periodic.
Yeah.
As like the wheel turns. And therefore it's A because it's the only periodic one.
Yeah, periodic. William mentioned periodic. This is very important, right? When you are on the Ferris wheel height, your height will just repeat itself every period, right? So among these four functions, only general sine function can be periodic, right? Okay, so for rumor spreading, maybe Natalie for rumor spreading.
For number starting, we chose diagram B.
Diagram B.
Yes, and because it says that start slow then fast, but
Mhm.
there are limited amount for in school, so to reach a thing where everyone just knows more. So then the acceleration rates slower.
Yeah, exactly.
And for the function, we chose the logistic one, which is L over 1.
Yeah, the logistical one, right? I have a simple question. What is the difference between rumor spreading and bacterial growth?
One has limit, but the other one doesn't.
Yeah, which one has limit?
One.
Rumor spreading has limit, right? Because we only care about the number of people inside the school who know the results, who know the rumor, right? And the number of people inside school is fixed. So there will be a limit here, right? So that's why we choose logistic growth mode. And for last one, let me do the easiest one. Production cost, so it will be graph D, and the function will be quadratic, right? It drops in the beginning because of the economies of scale, and then it will increase because of diseconomies of scale, right? So, yeah, you're right. So that's our starter program. What you can see from this? For different scenarios in our daily life, we can use what? We can use different types of functions to model it, right? Different types of functions can be used to model this phenomenon in our daily life. Actually, if we are able to view our world with the eyes of mathematics, we can find math is everywhere. This is actually what we call it mathematics modeling. It is also today's learning Google. I have to mention that it is also in alignment with our local curriculum standards called literacy. We will cover different parts of mathematical modeling today. Actually, there is a general flowchart for mathematical model. In the majority of time, modeling starts with curiosity. Just like what we talked on Monday, when people use microwave to cook the popcorns, he or she may be curious about the exact time to stop the microwave, to have as many as possible kernels to be cooked, be well cooked. So it is the starting point of our model. And in the end, he needs to check if the model is reasonable and do some verifications. It is easy to understand, right? But you guys have already found that I have this part missing. And this is the most important part because this is where our model comes from. I choose not to give you guys the full picture in the very beginning because I want you to learn from your own experience today. So at the end of today's class, we will come back to this flowchart to uncover this missing part. Okay? So let's get back to Monday. What we talked about the popcorn problem. So when I'm using the microwave to cook the popcorns, if the time is too long, the popcorns will burn, right? If the time is too short, I can only have few popcorns being cooked. So I'm wondering, what is the optimal time for us to use a microwave, right? So let's listen to a radio to recall our memories. This is recorded after I put the popcorns inside the microwave. And you can hear clearly the sound of pops, right? We can assume that each sound of pop means one popcorn has been exploded. So we can count the number of pops we hear, right? So we can get our data, our number of cumulative popped kernels with respect to the time t. But this is a simplified version of that. Now you can flip over the two A3 sheets on your desk. This is the worksheet today, and this is your also your main task. You will find that there are 4 in this worksheet, right? And I have to emphasize that this is a group work, so please ensure everyone in your group is on the same page in the entire process. Okay? So now you can start with part 1 and part 2. You have 3 minutes to discuss, and 3 minutes later we will have a class share. I will also be around to help you.
It's just either
Por favor.
Okay, so is there anyone who want to share with us your group's finding about part 1? Part 1? I walked around to see your answers. I see all 5 groups all choose D as the best research question here. And I want to emphasize that there's no perfect research question actually, right? We define the research question to help us better manage our mathematical model, right? But so in the answer of Claudia mentioned specific and aim. I believe these 2 words are very important for us. So personally, I will also choose D as the best RQ. But I want us to have a quick discussion about what makes a good research question. What makes a good research question? I want you to share your ideas with us.
I think good research questions first is
You can just share with the class.
yeah, and it should not have a like
Okay, Mike, you share with us.
Okay, so I think a successful research question must include like the aim for this research.
Yeah.
Why are they going to do this research and what do they want to achieve? And also like states the variables such as like the independent and dependent variable to make it very clear like what they focus on.
Yeah, exactly. What Mike says is quite right. Claudia mentioned the specific. I believe specific is quite important, right?
Yeah.
You need to know what you are going to do in the modeling process, right? And then Mike mentioned the aim, so I believe it should be solvable, right? It should be solvable, and for D, it also mentions the optimal time to stop the microwave, right? So it is what measurable. I believe these 3 criteria are very important when we are choosing the research question. So in the future, when you are doing your exploration, you need to try to make your research question specific, variable, and so on. Okay, let's go on. For the variables, as what changes, the other changes with it. Any? As time changes, and t changes. Number of polynomials will change with it, right? So the independent variable will be maybe time t, and the dependent variable will be p. We use the function notation pt to denote it, right? Everyone is on the same page? Okay, so we can move on. About the scatter plot, I believe you guys are familiar with the scatter plot draw. I also draw my own scatter plot on my computer. If I input the data correctly, we should get the same, exactly the same scatter plot, right? It should be the exact same. So, but my point is not on the scatter plot itself. I want you guys to answer me. Why do we need a scatter? Okay, Amy.
Because that wants to be able to see the general trend of the function to decide which family of functions we're going to use, and so we can use that and the data from the points to obtain our more specific function.
Yeah, exactly. Amy mentioned the data trend, right? Because we have defined our independent variable and the dependent variable. We want to get a clear picture of the relationship between them. So scatter plot will be very helpful here, right? So if I can draw a curve which like this, that is maybe probably the function we want to find, right? Okay. So and what do you observe from the scatter plot? Because like it is increasing or decreasing? Increasing. It is concave up or concave down? Concave up. So tell me your choice about the family of functions. Let me invite Emily.
We use like the exponential function.
Exponential function. Why?
Because if we see the start point, I think we find that this helps this is better for the exponential functions well.
Yeah. The trend is like the curve of the exponential function, right? So I walked around to see all of the 5 groups choose exponential one. I believe it's quite reasonable here. We choose the exponential function. And we find that t is the independent variable, p is our dependent variable. So we have a, b, c as our parameters to be determined, right? Parameters. So our next step will be trying to find the values for these parameters, right? Okay, so now you will have 8 minutes to work on part 3 and part 4, and I will be around to help you.
Isso ela falou ali, acho que é pra lá. Tem que seguir ela, com o de azul.
We will have a discussion about this lesson. Lifted.